Hello everyone, this is our third video in a series of videos on time series analysis in Python and Pandas. In today's video, we're going to learn how to download and manipulate financial data or stocks using Pandas and Python. In addition to this video, I have created a post that nicely summarizes everything that I will be explaining in this video. So if you don't have time to watch this video, you can just read the post because all the codes are provided over here. A link to this post is provided in the description below. To explain the code, I will be using Spider Python environment. Why I'm using Spider? Well, Spider is very convenient for debugging the code. And furthermore, since I like MATLAB, it reminds me of the MATLAB graphic user interface. For example, if I want to import these three libraries in Python, I will just select this piece of code and execute it. And here you can see the results. I strongly suggest you that you install Spider since it makes coding much easier compared to other graphic user environments. So let's start. First, I'm going to erase my old workspace. I'm doing this by typing reset and clicking on yes. Then I'm going to clear the screen. Good. Again, I have to import the three libraries. The first library is the Panda, the second one is NumPy, and the third one is the plotting library. Great. Next, I need to import a library for defining the date-time objects. These objects are used as arguments of a function that will download the data from internet. So I have to import the datetime. And finally, I have to import the Pandas data reader. Now, in your case, you probably don't have a Pandas data reader, so you need to install it. How to do that? Well, you need to copy and paste this code, and to paste it into command line, just type pipe install pandas data reader. In my case, I get this screen since I already have this library installed. However, in your case, you will not have this library installed, so you will see the installation screen. So what you can see over here is a history of the Amazon stock. You can have it for 1 day, 5 days, 1 month, 6 months, year to date, or maximum. Right? You can see that somewhere in 1999 the price was around $90, and today the price is $3,000. Okay. Now, what we're going to do, we're going to download this data and we're going to save this data into a Pandas data frame structure such that we can manipulate it. But not only this data, we are going to download other important financial data such as, for example, volumes, such as opening prices, such as closing prices, and etc. Besides downloading the financial data of Amazon, we are also going to download the financial data of Boeing. The next step is to define the start and end timestamps for downloading the data. So, we're going to look at the historical prices of Amazon and Boeing stocks starting from January 1st, 2020 until January 1st, 2021. So, by executing these two lines of code, you're basically defining a datetime object and you specify the date. These two dates are used as an argument to a function for downloading the data. So, this method of the Pandas data reader or functions, member functions of the Pandas data reader are used to obtain the data. You specify the ticker of the stock. This is the standard abbreviation of the Amazon stock. So every stock has its own standard abbreviation. For example, Boeing is BA, Amazon is AMZN. Then you specify as a second argument the start time and you specify the end time. So what this function will do, it will go online, go to the Yahoo Finance website, grab the data and save it into this data frame, Pandas data frame object. So let us execute these two lines of code. Okay, so perfect. Now we have our stock data. You can simply check this by typing Amazon. So what you can see here is a data frame containing dates in the first columns, the highest price at every date, the lowest price, and other columns that we will explain in the sequel. As always, there is another way for defining the timestamps and for downloading the data. So instead of defining basically a datetime object, you can simply provide as an argument a timestamp. So pd.timestamp is basically a pandas function that defines a timestamp. You specify the start date, the end date, and by executing these two code lines, you will again obtain the stock data. I personally prefer the first method. Although it's more verbose, it's more clear, to me at least. Next, let us investigate the data. If you type amazon.head, you will obtain the first few rows of the data frame. Then you can get the indices by typing amazon.index. So these are the dates, right? Then you can get the column names, a very useful function. So you can see that the column name is the high, low, open, close, volume, adjusted close. The first one is the highest price, the second one the lowest price, open price, close price, volume, how many stocks are being traded during the day, and adjusted close. It's basically a close price subtracted by dividends and other amenities or other quantities that are being added to the stock price. Next, you can plot the first few rows. Actually, the values right at the first few rows. Then you can also basically store the values into an object. So basically typing amazon.values, here are the values, and you can store it into an object. Let's see what do we have here. You can type shape. Okay, so basically it's a matrix of values. We don't have columns anymore, and you can type whos to see what is the type of the object. You can basically see that it's basically a NumPy array. So let us compute the basic statistics. By typing amazon.describe, you obtain something that looks like this. So what can we see over here? You can see how many entries are in the first column, what's the mean, what's the standard deviation, minimum value, and these are percentiles. This is the median over here. Finally, let us plot the data. So I've wrote a piece of code for plotting and also for saving the graph into a certain file. So by executing this, we can see a nice time history of our Amazon stock. So this was somewhere in January, then February, then Corona happened, everything went down, and since then the market more or less recovered. At least this stock recovered. Similarly, you can plot the Boeing stock. Here how it looks. This is the corona here. This is basically March, early March, then went down, and it's basically has this type of behavior, still didn't recover. Now, you can also plot another column. You can see here the result. Then we can save data to a file. Basically, with this function to CSV, this is a Pandas function for saving the data into a file. You provide as an argument the name of the file. By executing this, you're going to save your data to a file. Then you have to notice here that the file is being saved in this folder. Okay, so this is the folder where your file will be saved. Then you can load the data from the file by executing this line of code. Let's see what happened. Here it is. This is the data that's being loaded from the file, Amazon data. So let's plot it to see. Here it is. Perfect. So we can download the data, we can save it to a file, we can open it from a file, and we can plot it in few lines of code. Pandas data frame structure, or class better to say, has many functions. In this video I'm not going to cover all the functions. Actually, I would need probably several hours to explain all the possible functions. However, there is one function that I find very convenient. This is the so-called resample function. Okay, so what I'm going to do now, I'm going to compute a monthly average of my stocks, right? So I'm going to take the prices and I'm going to average them for January, for February, for March, etc. And I'm going to plot the result on a new graph. So how to do that? Well, if you type Amazon, you will obtain the Amazon data frame. But if you type, let's say, describe, or better to say head, you will obtain the first few entries. Now, how to select the last column, the adjusted close column? That's very easy. You just type Amazon and you specify the string name, the column name, right? And this is how you select the last column. Now, this is a Pandas series structure, right? So it's a class and it has certain methods. It has many methods. However, there is one method, .resample. So what you're doing with this, you're basically selecting, or you're making a sub-selection of prices for every month. And then on top of that, you can call a mean function, right? So by executing this, you will obtain monthly resampled Amazon. And let's see what is this. Here it is. Again, it's a Pandas series. For every month, you have basically the average price. Instead of calling this mean function, you can define, for example, a sum, which is not very meaningful in this case. However, you can do that. Or there are many other functions that you can call. You can look into the help. Now, this is basically the sum. In this case, this number doesn't have any sense. Okay. Now, let us plot. This is how we plot the resample data. Great. So, what can we see over here? These are monthly averaged prices. How about computing a difference between the open and the close price in every trading day? Well, you can simply select, by executing this code line, the open price, then you can select the close price. And let's say that we want to compute the difference between the open and the close price, and that we want to assign the computed series to another column that we are going to call the difference. By executing this code line, we can achieve that. Okay? Now, if we type Amazon.columns, we can observe an additional column that didn't exist in the original data frame. This is the difference column. And then we can simply type head to see. And this is our difference. So basically this is the difference in prices. And we can plot it simply by selecting the difference and typing plot. Here is the difference, right? Very nice. You can simply delete a column by just typing delete Amazon difference. And let's check. Let's see what happens. Great. No column. The next operation that you will most likely perform is concatenation. So how to perform this step? So, for example, let's say we want to place next to each other the adjusted closing price of Amazon and of Boeing. So let's define these two time series. Now, with this code line, you can define a data frame that looks like this. So what can we see over here? The first column are the timestamps. In the second column, you can see the closing prices of Amazon. Since the first argument in this function, or actually in this list, is close Amazon. The second argument is close BA, and that's basically the adjusted closing price of Boeing. And you specify x is equal to 1. This means that you want to stack these two series column-wise. Okay? And then by typing close concatenate columns, you can see that the columns are adjusted close. Now, you can also concatenate everything together. So you can take the whole Amazon data frame and the whole Boeing data frame, and you can stack them together. Okay, let's do this and let's see what's happening here. Great. Let's see the columns. You can see now that the columns start from high and at adjusted close, then again start at high and they end at adjusted close. The first 6 columns, 1, 2, 3, 4, 5, 6, are the columns corresponding to Boeing, and the last 6, actually the first 6 are the columns corresponding to Amazon, and the last 6 columns are columns corresponding to Boeing. Great. However, there is another way for concatenating these two data frames, and this method is very elegant. So instead of just simply putting them together, you can define new keys such that you can easily access the data frames. So you can simply execute this code line, and let's see what do we get. Great, so what can we see over here? We can see now that we have an additional key that represents a ticker of the stock, Amazon and Boeing. So let's say from this data frame, this huge data frame, we want to find, or we want to select only the Amazon part. We can simply type concatenate amazon.head. Here it is. Now this is our Amazon data frame. How about accessing the adjusted close price? Here it is again. And then finally we can access the values for the date 2020-01-02. This method, this LOC, is explained in my previous video. This method is used to basically index by the index name. You can also index the number, actually index the elements by their position. In that case, you will use ILOC. However, you would need to know the place where the particular value is being stored. That would be all for today. I hope that you enjoyed this video. If you like this video, please subscribe or support my channel, and have a nice day.